Hey you, so glad we're doing this. Today we're going to crack the code on a math term that sounds way scarier than it actually is. Polynomial zeros. I promise, by the end of this, you'll see just how simple and even visual this whole idea is. Let's just dive right in.
I know, right? It's one of those things you hear in class, and you're just kind of supposed to nod along. But what is a zero? What are we even looking for? Don't worry, we're about to make it super clear. And we're going to do it with pictures, which honestly just makes everything make more sense. Okay, so here's the official, super formal textbook definition. It says some number k is a zero if you plug it into the polynomial for x and the whole thing spits out a zero. I mean, that's the math speak. But let's just forget the words for a second and see what this really looks like on a graph, because that's where the magic happens.
We are going to start with the basics, something you've probably known for years. A good old-fashioned straight line. Trust me, this is the foundation for everything else. So if we get this, the rest is going to be a piece of cake.
Remember making these little tables? All we're doing is taking a simple line like y equals 2x plus 3, and we're just plugging in some numbers for x to see what y turns out to be. So if x is minus 2, y is minus 1. If x is 2, y is 7. These points help us draw our line, and somewhere on that line, we're going to find our zero.
And here's the line. Now, the most important spot on this whole graph for what we're doing is right there. See it? Where the line cuts right across the horizontal x-axis. At that one exact point, the value of y is 0. And that, my friend, means the x value at that point is the 0 of our polynomial. That's literally all it is.
Okay, you're a pro at straight lines, so let's level up to something a little more fun. A quadratic polynomial. Instead of a straight line, this one gives us that awesome curve called a parabola.
So let's do the same thing with our parabola's equation. Whoa, wait a second. Look what happens in the table. When x is -1, y is 0. And look again. When x is 4, y is also 0. How cool is that? We just found two different x values that make the whole polynomial equal 0. These are our zeros.
And check this out. When we graph that parabola, those two numbers we just found in the table, -1 and 4, are the exact spots where the curve crosses the horizontal x-axis. It's just a picture of what the numbers told us. Those are our two zeros. See how it works?
So a line crossed just once. Our parabola just crossed twice. But does it always have to be 2 for a parabola? Nope. With these curves, there are actually 3 possibilities. Let's check them out.
Okay, so on the left, that's what we just saw. The curve dips down and crosses in 2 different places, giving us 2 zeros. Easy. But now, look at the graph on the right. See how the curve comes down and just kisses the x-axis? It just touches it at one single point before going back up. This is what it looks like when a polynomial has only one zero.
So we've seen 2 zeros and 1 zero. The third possibility? Well, what if the parabola just misses the x-axis completely? It might be floating entirely above it or hanging out way down below. If it never crosses that line at all, well, then it has no zeros. Simple as that.
So here's the big takeaway for these U-shapes. For a polynomial of degree 2, that's our parabola, the absolute maximum number of zeros you can have is 2. It can be 2, it can be 1, or it can be none, but it can never be more than 2. And you know what's cool? This pattern doesn't just work for lines and parabolas. It holds true for even crazier, wavier polynomials. And it all leads to one simple, super powerful rule that you can use for any polynomial you ever see.
Okay, let's look at a cubic polynomial now. That just means its highest power is 3. Look at its graph. It's like a little roller coaster. Just count with me. How many times does it cross that flat x-axis? 1, 2, 3 times. So can you guess how many zeros it has? Yep, 3.
And this right here is the golden rule. This is the main event. The degree of the polynomial, that's just the highest little exponent you see on an x, tells you the maximum number of times the graph can cross the x-axis. A degree 2 has at most 2 zeros. A degree 3 has at most 3. A degree 100 would have at most 100. It's that powerful and that simple.
Okay, you totally have this now. Let's do a quick fire round. I'm just going to show you a graph and you tell me how many zeros it has. No calculators, no hard math, just looking. Ready?
All right, first one up, just take a look at this graph. How many zeros does it have? Remember, all you got to do is count the spots where it hits that horizontal x-axis.
That's it, just one. It crosses the x-axis at just a single point. You nailed it.
Let's do another.
Okay, here comes the next one. Take a peek.
Same question. How many zeros does this one have?
2 is right. Perfect. It crosses once on the left and once on the right, giving it 2 zeros. You're on a roll. Okay, last one.
All right, last one. Now this one looks a little more complicated, but the rule is exactly the same. Don't let all those wiggles fool you.
From the final challenge, how many zeros do you see here? Take your time and just count them up. 4. The answer is 4. 1, 2, 3, 4 intersections. That's it. That's all there is to finding the number of zeros from a graph. You just have to count. Fantastic job.
So if you take away just one thing today, please let it be this. Zeros are just a fancy math name for the x-coordinates of the points where the graph hits the x-axis. That is the whole secret. It's not about some big, scary formula. It's just about seeing where the picture hits that line. You've totally cracked the code. Well done.